Hello everyone. Today we will study the classification of haloalkanes and haloarenes, right? So as you can see, like haloalkanes and haloarenes can be classified as follows, like on the basis of number of halogen atoms. Okay, like this can be classified as mono. If it is only one halogen atom, then it will be mono. It can be di when there will be two halogen atoms. It can be polyhalogen when there will be more than two halogen atoms. Like this can be tri, means three halogen atoms, tetra means four halogen atoms, etc. Okay, yeah, depending on whether they contain one, two more halogen atoms in their structure. Okay, for example, let's see. So this is actually C2H6. From these you can see only one of the hydrogen is replaced by only one of halogen, only one of halide. X can be anything from halo, so it is named as mono haloalkanes. The mono is because only one halogen is attached to this carbon atom. Second is dihalo. For example, this is CH2, like there is two carbon atom, and on each of the carbon atom there is one halogen. Okay, so yeah, yes, just make sure that the valency of carbon atom is fully filled. Like carbon has four valency, so 1 2 and 2 hydrogen, so it will be 4, so it is correct, right? So it will be dihaloalkane. Similarly, it can be trihaloalkane when there is when there will be three halogen atoms. So this is the aliphatic, like there is long chain of carbon-carbon bonds, single bonds. Similar things can be happen when there is aromatic rings, like this is arene. Arene means benzene ring. Halo means there is only halo means there are any halogen elements are there, halogen atoms are there. Mono means again only one, so this is mono, this is di, this is tri. Okay, so monohalo compounds may further be classified according to the hybridization of the carbon atom. Look at this point, this is the hybridization of the carbon atom. Now you know what is hybridization, right? Hybridization means basic, in a simple way, is the like mixing of two orbitals, we can say. So mixing of two orbitals can form the hybridization. As you know, hybrid means what? Mixing of things. So this can be classified according to the hybridization of the carbon atom to which halogen is bonded. Like this carbon atom, this halogen is bonded to this carbon atom. So what will be the hybridization? What will be the hybridization of this carbon atom? This is the important thing. This will matter, right? So the compounds containing sp3 carbon CH, this carbon, like for example this carbon is sp3. Okay, this sp3 and this is bonded to any halogen group. So this can be classified as alkyl halides or haloalkanes. Again, alkyl halides means any haloalkanes, like Rx. This R can be any alkyl chain. This can be CH3, C2H5. This way it will go around. So just give a read to this. In alkyl halides, the halogen atom is bonded to alkyl group. This is the alkyl group. They form a homogeneous series represented by CnH twice n plus 1x. This is the general formula of this. So as you know, CnH twice n plus 2. What is this? CnH twice n plus 2. CnH twice n, only twice n. What will be this? Just comment down then what is the compounds of this formula. Okay, so if it is like plus 1 and then x, this is comes into the consideration of alkyl halide, and they are further classified as primary, secondary and tertiary according to the carbon nature of carbon atoms to which halogen is attached. Now for example, this carbon, okay, this is sp3 carbon, right? As in the name, this in the font size, like it is sp3 carbon. So this carbon is sp3, right? Now it is primary. Why it is primary? Because if halogen is attached to a primary carbon atom in an alkyl halide, the alkyl halide is called primary alkyl halide. If there is Similarly, if halogen is attached to the secondary carbon atom, so now what is primary and secondary? So this carbon, it has two hydrogen. If it is two hydrogen, then it is primary. If in this carbon, if it has only one hydrogen, then it is secondary. In the carbon atom, if there is no hydrogen, look at this, there is no hydrogen, these are only R, and R means any alkyl group. These are not hydrogen. So these are tertiary. Okay. Now, on the basis of this hybridization of the carbon center, this can again classified as primary, secondary, and tertiary. Okay, this most easiest way to remember this, like look at this tertiary. Tertiary means there is no hydrogen atom on the carbon atom. So एक भी carbon atom, एक भी hydrogen नहीं है इस carbon atom पे, so it is tertiary. When there is only one hydrogen, then it is secondary. When there is two hydrogen, then it is primary. Okay, I hope you can remember this. Now come to this point, which is allylic halides. So allylic halides, look at this point, look at this carbon, and look at this carbon. Okay, this halogen is attached to this carbon, which is sp3. Okay, and the surrounding is sp2. This is like sp2 carbon is connected to the sp3 and then halogen. So this is known as allylic. This carbon is known as allylic carbon. Remember this carbon is known as allylic carbon, and with this carbon, if any halogen, any group is connected, then it is known as on the basis of allylic position. Look, I can read out for you. These are the compounds in which halogen atom is bonded to an sp3 hybridized carbon atom adjacent to carbon-carbon double bond. Adjacent to, like this, carbon-carbon double bond adjacent to this sp3. This is known as allyl halide. Similarly, this is known as allyl halide. Allyl carbon is this, which is not the benzene ring. It is just normal cyclohexane ring, and on cyclohexane it has one double bond. And this position is known as allylic carbon.